Okay, let's keep building. You've graduated from 6th grade, you're moving on to 7th grade. And in 7th grade, all we do is we add a second step. So now two things are going to happen to the x, and we're going to do two steps to figure out what x is. So for this, let's just kind of continue with this theme of twos. We'll do two examples. I'm going to make a little like thought space on the sides just so we can add some notes. School day's over. All right, so for example 1, we're just going to write a classic 7th grade equation. You know that one, 3x plus 5 makes 23. We've all seen this before. I'm going to zoom in just a little bit. Okay, so 3x plus 5 makes 23. I'm going to skip down. Let's do this. 1, 2, 3, 4, 5 spaces, and then I'm just going to set a little target here. So notice I'm just going to line up these equal signs. I have x on the left, I have my numbers on the right. So the goal is to get that x by itself. But step 1, I just want you to focus on what we're doing here, right? So 3x plus 5 makes 23. So we're multiplying x by 3. We're adding 5 to it to get 23. So I want to get this x by itself. So the first thing you should notice, though, is that I have a number here and a number here. Okay, so I've identified my variable. Next thing I see is I have these numbers. So I want to put these together. So the way to make this go away is to use your inverse operations, just like we did in 6th grade. Right, so the opposite of add 5 is subtract 5. Anything I do to one side, I do to the other. I do this so that this goes away. But what that's going to tell me is whatever is under my finger has a value of whatever 23 minus 5 is. So 23 take away 5 is 18. What that tells me is 18 plus 5 makes 23, but in this hole, there's a 3x. Right? So 18 plus 5 makes 23. That's where this comes from. But what does that 18 represent? It represents 3 x's. So you should already be combining now two of our steps from 6th grade, right? So when I see something that looks like that, where x is attached to a number called a coefficient, to get rid of that number, I do the opposite of multiply, which is divide. So 3 times x makes 18. To figure out how much 1x is worth, I divide both sides by 3. 3 divided by 3 cancels out, just becomes 1x. 18 divided by 3 makes 6. Right? So the idea is still the same, except we have one inverse operation here and another one here, right? So just here, let's just think about what we did here. So in 7th grade, step 1 is to identify the variable. So basically, I just do that by boxing. Step 2 is to combine. I'm going to use a fancy math word. So combine the constants, that just means hashtag numbers. So notice like 5 and 23 aren't attached to an x, so we just call those constants, right? They're just, we know what 5 means, we know what 23 means, it's always going to mean the same thing. But because they're similar, right, number and a number, we can combine them. Right? And that's where we're using our inverse operations. And then step 3 is just going to be to multiply, or sometimes you can divide. So I'll put that in parentheses. So multiply or divide to find x, or y, or whatever it is, right? So maybe we should change that up. So here's our steps. Let's see if we can do it one more time. Example number 2 for two-step equations. Let's say we have 9 minus, and we'll just be funky, 4c. So we're going to solve for c. Makes 31. Okay, so 9 take away 4c makes 31. Right? Step 1 is to identify the variable that we're solving for. And so what I'm going to do is box that whole thing. So I'm actually looking for, I'm first going to try to get negative 4c by itself. Right? So I don't want to touch anything. These are connected. We can't break them apart yet. But if you notice, there's just a 9 hanging out. It's just a positive 9 because there's no symbol in front. So how do you get rid of a positive 9? You take it away. So step 1 is going to be just take away the 9. Anything I do to one side, I do to the other, right? 9 minus 9. 31 minus 9 is 22. Forgot to separate both sides, but that's good to do. And now I'm just going to bring down this negative 4c, right? So I know that if I were to do 9 minus 22, right, or excuse me, 9 minus, 22, that would give me 31, right? That's actually kind of strange. No, so if I added, excuse me, that's an add. So if I just had 9 and a 22 in that hole, that would give me 31. That makes more sense. So 9 plus 22 makes 31. But underneath my finger is a negative 4c. That's totally weird. Let's make that less weird. So the goal is to get c by itself. I need that negative 4 to go away. So I'm going to divide by negative 4. Divide by negative 4. Right? And I would probably do this in the calculator. So 22 divided by negative 4 gives me negative 5.5. Okay? I feel like that explanation might have been a little strange, but let's just revisit it. So here's my inverse operations. The weird thing was we started with a number. We didn't start with the variable. And so you just have to see that as it's a positive 9 that's just hanging out, and it's hanging out with a variable. So we just want to get rid of it first, okay? Because it's positive, we get rid of it with a negative 9. But if you just had a 9 there, and we plugged this in and times it by negative 4, that would make this a positive 22, plus the positive 9 would give us 31. All right, so the cool thing is when you solve these can always be plugged back in for here, and you can see if 9 minus 4 times negative 5.5, if that would give you 31. If it does, you're correct. We're going to practice this more. We're just easing into things. Hopefully this is still easy for you.